Good day, everyone. Thanks for joining this session. This is a recorded session of the presentation I gave in API Days Australia. My name is Paco de la Cruz, and this session is about how you can harness GenAI in your APIs to understand what are the potential benefits, the challenges, and pitfalls of this approach. My name, as I mentioned, is Paco de la Cruz. I'm a principal cloud solution architect working for Deloitte, and I'm recording this session from Melbourne, Australia. My specialization is on enterprise integration. I also work on establishing cloud platforms and building distributed applications for our clients. And my focus has been Azure and .NET. I've been recognized as a Microsoft Azure MVP for 7 years. And besides work, I'm married. I have two beautiful daughters. And on top of cloud and software engineering, I like to learn about health, parenting, and also body weight exercises. So the agenda for this session, first I'm going to give you just a very brief introduction, a bit of context of this session, right? Then we're going to jump into discussing what are prompts and prompt engineering. Then we're going to jump into the demo. Hopefully you enjoyed the demo. And this is how you can extend your APIs using GenAI. And then we're going to discuss the benefits or potential benefits of this approach, but also discuss the challenges and pitfalls of extending your APIs with GenAI. And then at the end, we're going to wrap some some key takeaways. It's also worth noting that all opinions expressed during this presentation are all my own, and they do not express the views of my employer. Okay, so we all know Gen AI is revolutionizing software engineering, right? This is from the way we generate code, we write code, but all the way to being able to build smarter applications, right? But really, Gen AI is, when we're augmenting our applications with Gen AI, this is much more than just chatbots, right? So most of the applications we see nowadays are about chatbots. Even with the RAG pattern, it's all about chatbots, right? But I believe we can use large language models together with prompt engineering to make our software solution a bit smarter, right? So really the question I wanted to address during this session is, can we enhance our APIs and make them smarter by extending them using GenAI, right? So my goals for these sessions are, I want to show you in a very small scale what's possible leveraging GenAI in APIs. I also want to inspire you to explore new ways of extending your own APIs using GenAI and LLMs. And then I'm going to discuss the potential benefits, what are the challenges and pitfalls of embedding GenAI into your APIs. Okay, so it's important when we're leveraging GenAI um, in our applications, it's important to understand what are prompts and what's prompt engineering, right? So we use prompts to interact with large language models, right? And these are the natural language instructions in which we define the task and the context for the large language model, right? And we use this iterative process to shape our inputs, our prompts that we give to the AI model to get the desired outcomes, right? And this is what we call prompt engineering. And there are some strategies that we can follow, right? So the idea is that we need to give clear instructions, give the clear instruction, the task and the context that we're expecting from the model. Sometimes it's good to provide examples of how we want the outcome, right? If our task is a bit complex, it might be better to split it into multiple subtasks, right? Sometimes it also helps to ask the model to provide the rationale or the thought process, right? And we need to test the prompt systematically, right? And we can also control the level of randomness or creativity we want from the model using a parameter that in some models called temperature. All right, so let's jump into the demo, right? So the scenario, I wanted to build a semantic business rules engine, right? And build an API that acts as a semantic business rules engine. And I picked the automated expense claim approval process, right? And I had some functional requirements here. So I wanted to build to use natural language, I wanted to use natural language to write the business rules. And I also wanted the business rules engine to use semantics, right? So this is to use the data of of the documents it's processing, but also the meaning of the data to apply the business rules. I wanted the rules engine to also support some kind of semi-structured data, input data, and I wanted to return the output as a structured JSON document, right? And then I also had some non-functional requirements as being able to change my prompts without having to recompile or change the code of my solution, and also to allow for automated testing. The source code of the demo I'm presenting today is on my GitHub. You can access it through this QR code. You will be able to see the code, the prompts, and also the test code as well. So now, in terms of the solution architecture, so first I crafted a prompt that I prepared for the LLM, that I'm instructing the LLM to behave as a business rules engine for an expense approval process. And this prompt also contains the business rules the LLM should follow. Now, in terms of the architecture, so I built this as a web API, and I'm using Azure Functions because this is the technology I use very often. And I built also a HTTP client that sends this expense claim in the JSON format to the web API, right? So the expense is going to be a JSON document that I'm going to be sending to my API. Now the API is going to be reading my prompt, right? So the task, the context, the business rules, and then it's going to combine that prompt with the expense document, and it's going to send that to the GenAI model, right? In this case, it's an OpenAI endpoint, right? And then I'm expecting the outcome from OpenAI to be a JSON document with the assessment of the expense, right? So it should tell me if it's approved, rejected, or if it requires a manual approval, right? So this is kind of the scenario. Now, so this is the prompt that I provided to my model, right? So I'm telling the model, you're a business rules engine specialized in expense claim approvals. You receive expenses in JSON format. You return your response in JSON as a JSON document. You return 3 statuses: approved, rejected, or requires manual approval. And then you need to specify a status reason, right? That you clearly state the rule that was applied, including the values in the claim that were used for the assessment. Right? I'm asking the model to be as precise and deterministic as possible. And I'm also instructing the model that when the data is not explicit in the input document, use the rest of the document to derive the data, right? So this is the task. And then I also gave some business rules. So I'm providing these business rules to assess expenses of type flight and expenses of type meals, right? So flight, I'm checking if it's a domestic or international flight. I'm checking the employee level, if it's a boss or not a boss. And I'm checking the amount of the flight as well, the expense, right? And then for meals, I'm checking if it's occurring during a weekday or a weekend. I'm checking again the employee level, and I'm checking the amount of the expense, right? So this is the structure of the business rules. So now let's jump into the code, right? So the same prompts that I showed you in the slides are here. So this is what I'm passing to the LLM, right? And then this is my service that is connecting to the LLM. And we're going to see that the C# code is super simple, right? So this is an Azure function, super simple. I'm using just initialization in my constructor. But first, I wanted to show you that so I'm providing temperature of 0 is in my app settings. And then I'm providing, this is a new feature from OpenAI, I'm providing the JSON schema that I'm expecting from the response. So I'm not expecting natural language only, I'm expecting a structured output, which is in the JSON format. And I'm instructing the model, I want an expense ID field, I want status field, and I want status reason field. All of these are required. Very simple schema, right? And then if you see here, I'm passing my prompt that I read in my constructor. I'm reading those prompts, the prompt and the business rules, and then the expense claim that I'm receiving in my request body, combining that into my request. Then I'm parsing my output, and that's it. I'm returning my output to the caller, right? It's very simple code, very simple solution. So I would say most of the logic happens on the LLM. This is just really a wrapper to call the LLM, right? So now let's test this from Postman. So for example, here I have an expense, have a date, expense of type meals, an amount, and a description. So let's send this to, so this is connecting to the web API, and then the web API is connecting to the model, right? So as you can see here, I'm receiving the JSON output that I specified in my chat completion options. I'm receiving the status and the status reason. In this case, this expense claim was approved, and it's telling me the reason, right? Now it's important to see here that I just provided a date, and the LLM was able to deduce that this was a weekday, right? So now this is different amount. Now this is rejected because this is above the threshold. And then this last one, I'm gonna send. And as you see here, it was able to deduce that this date corresponds to a weekend, right? But not only that, if we compare the first two, this has a type of meals. Second one has type meals as well. And the third one didn't have type meals in field, right? But it was able to deduce the type of expense based on the description, right? So it's kind of using some kind of semi-structured data and semantics here, right? So now let's jump into flights. So this one is recognizing that this is an international flight, right? And with this amount. Now it's interesting because I didn't specify the model how to know if it was international or domestic flight. However, from the description, the model grabbed the airport codes and it realized that it was from Brisbane to Dallas Fort Worth, right? And then based on the business rules, realized this is an international flight, this is for a bus. So then it requires manual approval because this is above the threshold, right? So now we send this one. This is Hobart to Canberra in Australia. This was recognized as a domestic for a bus, right? So this was approved, and so on and so forth, right? So the model is being able to make these deductions from the description and taking the meaning of the data. So this API that I'm building in this very simple code here, right? It's just a wrapper specifying JSON output, is behaving as a semantic business rules engine with the LLM backend. Now, I also have some test cases here that I will show you. Very, very simple. I'm going to run them while I show you the code of these test cases. So the same payloads that I used in my Postman collection, I have here in my test cases. Test cases are super simple. I'm just loading these documents from my file system. Then I'm grabbing the expense ID from the document in the arrange. Then on act, I'm calling my service, right? And then on the assertion side, I'm checking if the ID matches, and then if the status matches the expected. value, right? So if it's depending on the document, these are the statuses that I'm expecting. Now it's also interesting because if you remember in the LLM, I never specified how to do any kind of mapping, right? However, the model was able to realize there is an expense ID field here, and I have an ID in the input. So it's putting the same value in the output without me specifying that rule, right? So it was able to deduce as well that I should expect this value to be there, right? And that's what I'm asserting in my code. Here I'm checking if the expense ID is the same in the assertion, right? So I'm checking that the expense ID matches the result expense ID. Alrighty. So semantic features of the GenAI based business rules engine, right? So as we saw in the demo, the LLM was able to make these deductions, right? So it was able to deduce if it was a weekday or a weekend based on the date of the input expense. It was able to deduce whether the flight was international or domestic using airport codes in the description field. I never had to create a um, lookup table of airport codes and saying this airport code is in this country to realize if it's international, national, or domestic, right? And it was able to deduce also the expense type using the description field. So use some kind of semi-structured data supporting the meaning, right, of that description open field. And while I didn't put it here, it was also to make some mapping features there as well, right? So map the expense ID in the output. All right, so with that in mind, let's discuss the potential benefits, the potential challenges and pitfalls of this approach, right? So as we saw here, uh, GenAI is unlocking new and innovative use cases, right? So I was able to build a semantic business rules engine, returning a JSON output with a LLM in the backend, right? And it's very easy to start experimenting, right? So once you have access to LLM endpoint, then you can start interacting with an SDK, right? In this case, I'm using the OpenAI SDK. It's super easy to start interacting. We can also gain productivity, right? Because as you saw, that my code was super simple, and I let all the complexity of the business rules to happen in the LLM. No airport codes, tables, no rules to define if it was a weekday or a weekend. All the mapping was done by LLM, right? We can have better collaboration between business users and developers. Now we can get also structured outputs, right? So as we saw, we specify the schema, and then OpenAI is able to return a JSON, which is what I expect in an API. And there are options to keep inputs and outputs secure, right? So like, for example, Azure OpenAI allows you to keep all these within your private network and have secure access control to your APIs. So yeah, there are a lot of benefits there. Now, it's not all good, right? So natural language is ambiguous, right? So if you have the business rules, then it's going to be hard for someone else to probably change the business rules, or you might have start having many different styles there, right? So it can be ambiguous, can be difficult to maintain as well. So once you start having hundreds of business rules, then it might be hard to maintain in my use case, right? But in general, natural language is ambiguous. Now, the models and the SDKs are changing constantly, right? So it's really hard to keep up. Sometimes you build a solution and then in 3-6 months, you need to refresh your SDK or your endpoint, and then you're going to actually need to change or refactor your solution because something has changed, right? So for this demo, I'm using, for example, a preview feature of JSON, and I had to connect to an endpoint in the US because it's still not available in Australia at the time of recording. Also, there are some underlying costs, right? So because we're interacting with the LLM, then it might be hard to forecast how much money I would need to pay for the LLM because this is based on use. There is also added latency, right? So because we're connecting to the LLM, we don't know how long the LLM is going to take to respond. So it might not be ideal for some APIs. testing is complex as well. So I was able to test some fields, right? So the status and expense ID field, but I was not able to test the status reason, right? So I'm not too sure if the status reason in terms of automated testing, the status reason made sense or not, because it's just open text, natural language, right? It's really hard to test. Sometimes we also face the build versus wait and buy dilemma, right? So sometimes we build a custom solution and then in 3-6 months time, it's already a product off the shelf, right? So we don't know if we should wait or we should start building something custom there, for example. And when we're using it to build APIs, then it's really hard to incorporate human oversight, right? So when you're building chatbots, you can keep disclosing this is a GenAI generated response. Just make sure you're assessing for accuracy. In the case of APIs, because clients will be interacting with these APIs, it's hard to incorporate human oversight. Doesn't stop there. So there's some pitfalls, or really the ugly part of using GenAI in your APIs, right? So the first one is, well, if you're using large language model, sorry, natural language, some LLMs are really hard, like they will struggle to get all the context, right? There's some nuances in your language as well, or your prompts. And even when you tokenize your prompt, right? So you have natural language, it gets translated into vectors or tokens, and then from the response is from tokens to natural language, right? So many things can be lost in translation there. Now, also behavior is unpredictable, right? So even if you set your temperature to 0, you don't know if what you're going to be receiving from the LLM is going to be always the same. It's actually, it's not going to be always the same, right? So it's something that you need to bear in mind. Now, sometimes you even get hallucinations, right? So you get very sound reasoning, but the output is incorrect, right? Even using temperature of 0, it happened to me in some of my test cases. So I had to tweak the prompts just to reduce the number of hallucinations. That doesn't mean I will never get hallucinations, but this is something you need to bear in mind. On top of that, these LLM models, they are a black box, right? So if your prompt is not working, then you don't know what's happening behind the scenes. So it's really hard to troubleshoot. And there might be some biases in the models. All right. So just to wrap up, some key takeaways of the session. So my demo of this session was an experiment, right? So I wanted to show you what's possible, but this is not an endorsement of an enterprise-ready solution. Like, I'm not suggesting you to build your enterprise-ready business rules engine, for example, right? It's just to show you what's possible. And I also wanted to highlight in this session that GenAI can help us building intelligent apps beyond chatbots, right? This is not only chatbots, we can build much more than that. It's very easy to start experimenting and learn as you go, right? And we can actually use LLMs to perform AI augmented tasks within our APIs that we saw, right? But the semantic business rules engine that we saw in the demo is just one of the many potential use cases that I want you to think about, right, in your own scenarios. And we need to consider challenges, right, when using GenAI in our solutions. And really, I hope that this demo and session has inspired you to try and experiment with different use cases in your APIs. And with that, I want to thank you for joining me this session and see you next time.